Okay, this is a little bit more complicated, maybe level 2, 2.5 kind of service call. It's a little bit older machine, 6000 with a basic with auto reverse. So mechanical panel, auto reverse. The complaint is it's blowing fuses. Somebody's blown a few fuses here, but 1 and 2 fuses are blowing. Anytime that I see 2 fuses blowing, I typically start to think about phase-to-phase shorts. Now, if it's just 1 fuse, it's typically a phase-to-ground short, which when I say phase-to-phase, I mean phase-to-phase. So these 2 are touching, these 2 are touching, or all 3 of them are touching, potentially, right? Phase-to-ground, I'm thinking of this wire somewhere along this machine is touching this, and therefore it's blowing this fuse by overloading the amperage and popping the fuse. And what happens is those fuses will typically turn black. Some of them will do like a metallic or even like a little red. Just depends on how they blow or how big the explosion is. Okay, so this one, we have a pretty good idea that these 2 phases are blowing because this is an older fuse. These are the fuses that were blowing. I've already confirmed that those are the 2 fuses that were blown. I went ahead and put my fuses in there just to get in preparation for this. I have the power on at the moment, and what I'm going to do is I'm going to check preliminary checks. I want to make sure, first of all, that all my power is good. Okay. Hang my meter up, and I always use my auto function so that I cancel out any bad voltage. The majority of the bad voltage, doesn't get all of it, but it gets the majority of it. Stick my black lead on right there, so I can have both hands here. I'm going to open this up, and this will allow me to have both hands to stick that in there. That way it can't really move around. Okay, so I'm going to check my voltage first. 240, 430, 240. Okay, we're good there. 138. For shits and giggles, we got 27. Okay, so we're good at this point on power. What I want to do now, we're going to stick that back in there. And since we have a shorting situation, a fuse blowing situation, I'm going to go ahead and roll to just to get a quick snapshot real fast. Nothing's shorted out. What'll happen if you find something shorted out is it'll ring and it'll give you a reading there. You know, we got some readings of contactors and stuff like that. We'll explain that in a different video, but nothing significant. So that's our neutral. So it's got a low reading because it's tied together with ground right there. There's a jumper between there. Safety wires, 36, kind of low, not bad. It's pretty low though. So nothing significantly sticking out right now. My next step is so I carry these little jumpers, right? And what I want to do is I want to lock this machine in going one direction, but I want to take the 480 wires out because I don't want to blow a bunch of fuses like somebody's done right there. I don't think that's a good idea. Typically, it's a little bit of an expensive diagnostic tool. So we're going to pull these out and we're going to remember what order they're in: red, blue, black. I'm going to remember that by going black, blue, red, 180 in reverse. Okay. So that's hooked to 120 volts there, the 120 volt tap. So obviously the other end of this is hot. We want to be careful with that. But since my 480 wires are pulled out, the machine will not move. I can go ahead and engage my forward circuit. We're actually checking motors, right? And what I was doing is engaging my brown forward, orange reverse, and purple end tower wires to pull those contactors, to pull that coil of that contactor in, so that I could check the motors on those specific towers. You know, it's going to be going either forward or reverse. One way or the other, I'm going to be able to check every contactor, every motor through right here. So there's some issue somewhere, but that's not really indicating that it's a motor. When it does indicate that it's a motor, it's usually, you know, it's like a decent amount of voltage, or it's ohming to ground pretty good. And the best way to do that, to check motors themselves, to check the windings, is I go to that ohm setting. I'm going to check here. 350 ohms, pretty high. 350 ohms, really high. And again, 350. So we'll check again on my reverse side. So this is going to be all the motors that are being called for a run in reverse. 430, 420, 427, nothing super high ohms. We're all good there. So these motors are all checking out good. Thinking of getting some voltage back on these. So something with that forward side is kind of giving me an indicator that there's something going on there, but it's nothing I can diagnose yet. So from this point, I'm not seeing anything on a motor necessarily that's sticking out to me, but there's something strange going on there. So what I'm going to do is, since it's across a phase short, I'm going to check here. So I'm going to light up my red wire, and I'm going to go to voltage, and I'm going to check for voltage on the other phases. Okay. Nothing. Okay. I'm going to go to my next color, blue. Do the same thing. So what I'm doing is I'm sending 120 volts down, sent it down the red wire. Now I'm sending it down the blue wire, and I want to see if I get anything back. 2.9, and there it is. So I'm sending the voltage out on the blue wire, which is completely separate, and none of the contactors are pulled in at the moment. So I just have a series of 3 wires going down the machine to the top of every tower box contactor. Now so these have no contact with each other on the machine whatsoever until the contactors are pulled in, which none of them are pulled in right now. So I have 130 going out on my blue, coming directly from my panel, and I've got it somehow getting over onto my black wire, and it's not the full 130. So, I think it's moving around in the wind. Maybe there's something that's a very loose connection, but somehow these 2 wires are touching, and black, if I remember correctly, blue and black. I'll take these up here. So that's my middle phase, and then black is my third phase, my first phase. So my first phase and my middle phase, and that's the 2, first phase and middle phase. They're swapped in here, but they swap on this side. So the natural state more than likely is first phase, middle phase. These 2 fuses are blowing. So I feel pretty good that the next step that we're going to take is going to find us short. So we'll go there next. We're going to look here on the first tower. I've already kind of done my part on determining if it was on the inner or outer half of the machine, and I've determined it's on the inner half of the machine. And what I did that is I went to the 7-tower machine. I went to the 4th tower. 4th tower on a 7-tower machine is the 4th tower from the inside, 4th tower from the outside. So it's right in the middle. It told me that it was back towards the pivot, and I'll show you how I determined that. So right now I have 110 volts on blue. On my blue wire, I have it jump directly to 110 volts. Okay. Shove my ground in there. Check blue. Okay, 135. So now red, going to red, I got nominal voltage, nothing really, nothing significant. We can ignore that number there. But if I go to black, just like in the panel, I've got a higher voltage. I had about 90, 88 to 90 at the 4th tower as well. And it's bouncing around because whatever's touching is kind of blowing in the wind, looks like, potentially. So what I'm going to do to determine if it's either towards the pivot, and follow that wire, right? It goes up under the pipe, goes towards the pivot, or if it's towards the machine, follow that wire, go towards the machine, is I'm going to split this black wire, take it loose here. Now obviously it's got 130 volts on it, so we need to be careful, but I'm going to pull one side out, and I'm going to set it off here to the side, make sure it's not touching anything. My black lead's still grounded, double check that I got blue, hot blue. Okay, I'm going to go up to power going out, so this is my black wire going out on the machine. I left it in the terminal strip. I can follow it right here. It goes out to the machine. Okay, I'm going to check it. Nothing. Okay, so I've got the wire going back towards the pivot. Again, I can tell because it goes that direction, right? I'm going to check it. There's my voltage again. So somewhere between this point, this tower, and that pivot, my black and blue wires are touching. So we're going to go find that now. Okay, so obviously this collector ring has seen better days. Looks like the lid's been missing for a while, and some things are zip tied, but that's okay. We'll see if we can figure out what's going on here. Looks like, and I'm just gonna stick my ground somewhere where I can get a good reading on ground there. I think that should work. We'll just prop it up in there for now. Okay, we're gonna confirm that we have our 120 on black. I've already taken it loose just to double check. So I got 100 volts on black. So they're touching, but kind of inconsistently. And so what this is going to tell us is this a pivot point issue or is this a machine issue, right? So I'm taking this wire loose that goes to the machine and I'm separating the pivot point from the machine at this point. So check the wire going out to the machine. It's not a machine issue. So now we're going to check the collector ring. It looks like it's going to be a pivot point issue. So it's either going to be somewhere in here or even in the cable between this collector ring and that box down there. So we're going to find that out here in just a second. All right, so I went ahead and separated the collector ring from the raceway. So the raceway is the wire, this bundle of wires that goes down through this collector ring, down through this pipe, into the riser pipe, and out this deal here. And it goes down, carries on down to the main panel. So we're going to find out, is this a collector ring issue or raceway issue? So we've got this is the collector ring. We've got 99 volts on the collector ring. Let's check the raceway. Nothing. So somewhere in this collector ring, this brush is somehow touching this brush. And we're going to determine how in the hell that's happening right now. The final result. So what I went ahead and did, I was real curious because when I rung these out earlier, I'm not sure I showed that. I did check phase to phase with my meter and it showed really nothing significant. And it still shows really high reading. It's almost 1,000 ohms. It's 0.9 K, right? K is 1,000 ohms. Whenever it's straight up touching, it's 0, right? If we want to check the continuity or the resistance of this piece of steel right here, that's 2.4. That's reading through the galvanized and everything. That's 2.4 to 4, just bouncing around because it's basically just grounded out to each other, right? Because the probes are touching the same thing. So when we have something like this, and it's showing us, what does that say? Yeah, 0.9 ohms. It's kind of high. It's really, really high. We'll go ahead and check the brushes themselves, the drums. So these are the drums right in here. It's hard to get that. These drums. Go ahead and check them. Can't see it. Same reading, 0.921. So something real strange here. What I did is I went ahead and popped this loose, and all you do is go ahead and show you. Now I've unhooked all the power here, so everything is dead now. But we'll go ahead and stick our screwdriver in there and just spin it. Pop that little keeper loose, and our brush will come apart. Okay, I've got a little bit of a melted point right there. So that small amount of plastic has now become a conductor. It's gotten hot and hardened between the two of these brushes here, the two of these rings. And so it's actually conducting just enough between this brass ring and this brass ring to blow that fuse. So I'm going to try to just swap this piece of plastic and this top drum out. Okay, the resolution on this one today was going to be bypassing that brush. Not necessarily bypassing, but moving it. So what I did here, you notice I took that brush all the way off just so it wasn't in the way. It was kind of a little bit safer that way. Right here on brush number 4, right there where that black wire is now, that used to be the pink wire. And then I moved, number 1 is detached there, so that's doing nothing. It's not attached to anything. And I took the pink wire out of here and wired that black wire directly into number 4. You can't see it, but it's the left of that tan wire nut's the black wire. going into lead number 4 for the collector ring. And then I, obviously put my system wire over there on number 4. And what that does is that the pink wire is unused in the Valley system here in West Texas because we have no end guns. The system just needed to be moving, kind of an emergency deal. Obviously don't carry a collector ring on my pickup, but this will eventually get a full collector ring replacement. 1, the lid's gone. 2, that kind of issue will cause more issues down the road, but this is a temporary fix to get us through the weekend so that they can water if they need to, and I don't have to put a collector ring. It's on at 7 p.m. So that's the solution. That's where we ended up, and that's it.